Hello everyone. We are Anthing06 from Sairam Engineering College, and our problem statement is improved onion storage technology for enhancing the shelf life of onion under the theme of agricultural, rural development and food.
The problem. Every year, India faces almost 30 to 40% of loss in harvested of onions. This is occurred due to the rise in due to the change of humidity, temperature, and growth of microbes. So this is that's why we take this it as a challenge.
Our solution is about smart onion storage system using IOT. So that it is basically the sensor that we use here is temperature and humidity sensor to look about the surroundings. And also we use fan and desiccant chamber to alter the atmosphere in the chamber too. It is also to be known that the data are shown in the dashboard for the farmers, which is henceforth affordable, friendly, and also on modular.
In our prototype, to preserve onion shelf life and to extend shelf life of the onion, we uses IoT and smart systems to control the environment inside our prototype. That is like first of all, the onion gets rotten due to the increase of carbon dioxide, and the onion has a fungus name called asparagus niger, which forms ethylene. So due to the formation of ethylene, the rotten of onions gets spread inside a closed system. So what is the problem here is, whenever the highly decomposition, the highly deposit of carbon dioxide inside the closed system makes the onion to spread the rot overall to the stock of onions, to make the stock gets rotten by 30 to 40%. So to prevent this, we made a smart storage system. So what are the components we use in our prototype is, we use a CSP32 S series as a microcontroller to control our overall subordinating equipments with, so what are the equipments we use is our BME sensor. BME sensor, it is used to it is called as barometric sensor. So with that sensor we use it is used to measure humidity and temperature inside our prototype, and we use this a relay module, a single relay module to switch on a 12-volt fan. That is what I said before. Like our prototype needs an air circulation, so we use this relay to switch on our fan whenever the temperature increases or decreases. What is the problem here is, whenever the humidity gets higher, the asparagus niger fungus starts to grow rapidly. So to control the humidity, we use this system as a we use this system to stop the growth or to extend the shelf life of our onion. And here we use as NTC. So it is a negative temperature coefficient sensor. This NTC sensor is used to measure the temperature inside our prototype. To measure what is the temperature it is actually occurring inside our prototype. So then we use a PDC sheet, that is a it is used to heat nickel chromium iron steel wires or a sheet metal plate where it gets heat. So whenever the climatic conditions change into rainy seasons, so this method is gonna to switch on. So whenever the humidity rises in outermost environment also, so this PDC sensor is gonna act as an intermediate between the fans and the cooling environment. So this is the circuit that we are using in our prototype. Here the NDC diode detects the temperature and switches off or on the fan accordingly. Here the NDC sensor detects the rise in temperature and stops the fan. These data are noted in our dashboard, and switches on the fan when the temperature gets normal to
Our
ensure the
project
airflow
focuses
inside our
on
prototype.
making onion
And
storage safer
the
and
PDC
easier for
diodes
farmers.
are
We
operated
identified temperature
according to
and
the
humidity as the key
dependent
factors that
environment
affect
in our
onion
prototype.
quality.
Next to our
In Blink,
dashboard.
we created virtual pins for parameters like temperature, humidity, fan status, text alerts, and LEDs. Then we designed a dashboard with gauge, labels, and color coded LEDs to show whether the conditions are normal, warning, or critical. Using ESP32, we connected the sensor readings to these pins and synced them with the blink cloud. We also automated the fans so that if the temperature or humidity goes beyond the safe range, it turns on automatically. This way, farmers can monitor and control their onion storage container directly from their mobiles in a simple and farmer friendly way.
Getting back into the dissection part of the prototype, if you look into this, we do have a lot of aerational part where the air, where we would fix the fan over here, and the air flows into this chamber and comes out. And this is adiabatic system that I would like to inform you guys. So after keeping this stuff into this, we would close and seal it, and the air goes from the top to bottom. I'm just keeping it in a reverse way, and it goes to this hole where we have given for an aerational part. So you can look into this, we have just made a lot of holes so that inside this, the thing is that the air will go up and down so that it would take off the toxic gases from the bottom to up, and we have given a ventilation part over here. So the simple concept, hotter rises, it goes and comes out from this ventilation part. So we are using of this mode to be cheap, affordable, and also farmer friendly.